Hi folks, Vulcan Boiler Handhole Cleanout cover. This is a cast iron part. We've got to machine some really interesting cam and fixturing here. I think I'm more excited about this Wednesday widget than I've been on any in a long time. Let me take it apart and show you how we're going to fixture it, and then we're going to hop into Fusion. This is so cool. Welcome to another Wednesday widget. So what is this? It's a cast iron cover that goes on a locomotive or a train. It's a project for Keith Rucker. If you haven't seen Keith's YouTube channel, card here. Keith's a great guy. He does some really cool stuff, mostly manual. And guess what? The task at hand is to machine a groove for this ring, and that screams CNC. This is going to be an easy job, knock on HDPE. So let's show you. I spent some time thinking about this fixture. Let me show you what I've got here, and I'm going to tell you why I didn't do it a few other ways. And then I want you guys to tell me if there's a better way or how you would have done it. So the task at hand, as you can see from Keith's drawing, is to machine a groove about 3/8, help if I turn the drawing correct way, 3/8 of an inch deep and about 1/2 inch wide. The good news on this project, the tolerances are real loose, nothing crazy from a machining standpoint. The bad news is two things. One, tricky to fixture. Two, it's cast iron. I think I've only machined it once before, and it makes a mess. Wasn't going to turn the job down because of that, but I was excited to do a collaboration with Keith. But man, cast iron ain't fun. It should be pretty easy to machine though. So again, the idea is this ring is going to slip over this. What the problem is this screw, period. Now, we have enough room on the Tormach where we actually, the spindle here has enough clearance to where we could actually just hold this and machine it around just like so. And obviously, that would be the easiest way to do it. The problem is this was a cast part. There's a taper there. So there isn't a really easy way to get this exact geometry or to hold it with that taper, because even with soft jaws, as you pinch on them, it's tricky. By the way, card here to Keith's video. This is a collaboration, so Keith is going to film some of his side, which I believe, I haven't seen the video yet, but I believe it's about how they, more about the project, the train, how they came up with the casting, the pattern making and all that, so definitely check that out. I had really wanted to machine this using the 4th axis, because I thought, hey, I can stick the thread through the 4th axis on the Tormach chuck, and then hold it like this, and then I can rotate the part. Now we're using a 1/4 inch end mill, low tool pressure, short stubby tool, and to interpolate around this. That's not going to work because this shaft is bent and has run out. It's basically not centered enough. It's about 20 or 30 thou off center, and the bend makes it just not practical. However, as you can see here, we did figure out the Fusion 360 Toolpath to do that. So stick around, folks, or click the subscribe button, because I'm going to figure out another project to show you guys how to machine an oval on the 4th axis. Super useful. The other way, again, was soft jaws. I even thought about using, Tormach sells it, it's that melting plastic stuff to, like, basically, you could put it in the microwave, you could put it into some soft jaws, let it start to harden, clamp down. But again, the problem was getting it level and square and work holding and rigidity. So this is what I came up with. I find myself to be a very mediocre fixture maker, or rather, I'm always impressed when I see people make creative fixtures, and I try to take pictures or mental notes. But two things occurred to me. One, I've got this relatively flat surface, which is sort of what I want to be parallel to the machine surface. And two, I've got this thread here, which is pretty strong. So I just thought, you know what, I've got to make use of that. And so I started thinking, how can I machine it upside down? The first thought was, well, how do I get to do my cutting? And I quickly realized, wait a minute here, we could just use a woodruff cutter. There's plenty of room to reach underneath that and get it. And then I thought, well, I can't have the part touching this, so we got to lift it up. So we got some gauge blocks, no big deal. And then I thought, well, I got to hold it down. And that wasn't too tricky. The fact that the screw's at an angle bothered me. And so I thought, well, I'll put a nut on here and a washer, and then something to pinch against, and then something to pinch this against there. And so I found some steel rod that happened to fit through here. I got the thickest, stiffest stuff that I could, so it flexes the least. And then I found this piece actually came with in the pile of the lathe that we bought, that big 17-inch lathe, so I didn't have to make anything. Plenty strong, big chunk of steel, you know, about 3/4 of an inch thick. And boy, when we tightened down, you saw us loosen it, there's some clamping pressure there. So this fixture though has at least one fundamental flaw, maybe more, we'll find out. The fundamental flaw is as I tighten it down, I'm not gonna get this thing perfectly square. In other words, it's going to be at some sort of an angle. And I thought, well, okay, I'll loosen it a little and I'll then bump it in and tram it in. But boy, it gets tricky because I can't get my big socket down here and it can't get a crescent wrench in there. And I want to keep these tight together because that's going to improve the rigidity of the fixture. And then it occurred to me, wait a minute here, we can do this in Fusion. So let's hop over now to Fusion. Let's model this up and I'm going to show you how I don't care what angle this is at because we're going to let the computer do all that hard work. So we've got a 4 1/4 by 6 1/8. That's the inside oval, and then that extends out the 1/2 inch and down by 3/8. So Fusion 360, right click. I'm so excited for this. If it works, new component. Call it terrain part. Sketch, ellipse. I'm going to create it on this plane here. Turn my origin back on. At the center point of my origin, click, drag out, and then drag out again. Okay, wrong dimensions, don't care. I've got my 2 lines, which I can now define. Hit D for dimension. The longer one was 6.125. D for dimension. 4.25. So that's my inside ring. So the 1/2 inch part is further out. So go to Sketch, Offset, so easy. Click on this. How far? 0.5. We're like, yeah, I love this. Okay. I don't need to extrude it yet. What I want to do now is build out this idea I've got for how we're gonna adjust this part. When I created my ellipse, I created it perfectly left to right. And so see how we get this little constraint here? The Fusion 360 needs to do a better job of letting you label and see and edit constraints, but it's the one that looks like this. It's terrible, but nevertheless, what I want to do is I'm going to click on that once and hit the delete key. And what that's going to let me do is pivot this thing left to right. Good. I'll pivot it down a little. L for line. I'm just going to sketch a line up here somewhere. Now this one, I want to be horizontal. So see how it's got that constraint because I sketched it straight left to right. D for dimension, from the point to here, we'll just say is 4 inches. I don't think this distance really matters, it just needs to be consistent for now. Click on this line once, change it to a construction line, sketch point, point here and a point here. Now I want to dimension those points off a center line actually, so click here to here. I want these to be 2 inches. And I want the same for here to here. So I'm going to click the 2. Notice how right now it's ready for me to type 2. I don't want to type 2. I'm going to click 2 just to link it. So they have 2 points that are equidistant off the center of the part. Now what I'm going to do, L for line, click on my point here. I'm just going to drag down to about here. Escape, L for line, do the same thing over here. Coincident, I want that point to be coincident with this construction line. I want that point to be coincident with this construction line. D for dimension, click here, type in 4.05, whatever I want. D for dimension. This is going to be an output dimension. That's okay. It's basically saying you can't tell me what that dimension is because you've already told me enough other things that is a fully constrained thing. So I'm just showing you the output. What this is going to let me do is, let's say that this is 3.66. It's going to let me, we're going to go over to the computer right now, or the Tormach right now. We're going to set up our fixture, set up our part, put it in there, use the Heimer to measure 2 points, each 2 inches off center, and I'm going to look at those values, and we're going to come back here and adjust how the part is actually positioned in the fixture, and we're done. The CAM is easy. The CAM is a 2D contour. I'll post the speeds and feeds when we're running the part. Let's rock and roll, folks. 246 blocks, just great. I absolutely love them. They're so much better. 1, 2, 3 blocks are great, but having these, they're just so helpful. I actually got to buy another set because we only have one. So the idea is these pins happen to be a really good fit. As you can see, there's not much slop. That has the added benefit of keeping these blocks parallel, which just helps because they are going to get forced to parallel when I put it in the 6-inch vise. So the way I was doing this last night was I forget about the gauge blocks for now because this is a little bit awkward. Get this up here, get my nut to turn it. This was awkward, well, yesterday, let alone now that I've got 2 cameras in front of me. Okay, now, be careful I don't drop this whole damn thing. Although if you're new to our channel, feel free to laugh yourself away at our mistakes with our bloopers video card right here. We had a heck of a fun time keeping that footage and compiling it into a good number of mistakes. We've all been there though. Actually, there were some pretty funny internet heroes in the comments on that video who have apparently never made a mistake in their life. So I don't want to come up all the way, just close. Now, 2 half-inch gauge blocks. Oh shoot. I screwed up, so sorry. We need to test the fit of this ring, speaking of bloopers, and this ring is just disposable. Keith said he's got a lot more of them, so don't worry if we screwed up. So I don't want to take this thing out of the machine, so I need to take this off, put this ring back in, and leave it in there when we machine it. So hold on, let's fast forward through this. Gauge blocks are super helpful to have in the shop. They just are. I have no problem buying the Shars sets, and again, people are going to yell at me because I'm not wearing, gloves to keep your hands and oils off of these. Look, we don't do tenths work on a regular basis. It wouldn't be a bad idea for us to keep a second set of gauge blocks that we use for metrology, but the truth is I need a set that I can use, and that's this set, on a regular basis, and don't drop it like I just did. That is really stupid, sorry. But I need a set that I can use for setup work like this. Cool, so that keeps my part flat. Okay, I got the nut snugged, and actually this is exactly what I was talking about. It's really difficult, now that I've got the gasket in there, to keep the gauge blocks in place. Maybe there's a better way that I'm not thinking of. So I had Jared hold it while I tightened the nut, or vice versa. But now you can see, this is not perpendicular or parallel to my X. So that's the problem we got to solve, which is what we're, I think, going to take care of pretty easy. The old knock test, I mean, that hurts. That's solid. That's not going, well, knock on cast iron, that's not going anywhere. I also just talked to Keith because I realized the casting is oversized around the periphery. So that presented a problem because I don't have enough cutting diameter on this woodruff to come all the way underneath unless we trim it down on the outside. And Keith said that's actually perfect because the casting was just, oversized anyway. So we're going to trim this down to the correct size and then come in with the woodruff. Divided that by 2 in the DRO, and that gives me an X0 of dead center in the part. Perfect. Okay, so now we're at X0. What I'm going to do is come to X -2. Come down to the same Z point, just to try to be consistent. And I've got to sneak around and look before we do this. yeah, we're okay. First, I want to establish this. It doesn't matter what it is. I'm just going to go to an arbitrary distance here and set Y0. So I've established this fake line right here. It's not the same as the like 3 or 4 inches we had in Fusion, but I just need a known distance to go between this point here and then that same point over here and back. So I'm going to come down and see where does my Heimer equal 0. Right there. So my Y dimension in PathPilot is negative 7.642. Go over to the right side. So go to positive 0.2. .7647. There's no way. Oh, come on. I think we're like, that's impossible, folks. We're 5/10. Oh my God, come on. The whole point was this thing was supposed to be crooked. I mean, still, what? Let's check on the front side, just to see. Okay, that's more like it. This shows that I'm 23 thousandths out. Now here's the thing. These are loose tolerances, and it's all, what I care about is the fit of the O-ring over the place that we're going to machine. So I can't emphasize this enough. You know, it doesn't matter. There is no such thing as tenths of an inch on a cast iron plate. But believe it or not, and I'm sorry, we're actually far more square than I intended to be. Okay, so what I was supposed to do now was to come and impress you guys by saying that, let's say there was a 0.2 difference in Y dimension. So this center dimension is 4. So if I type 4.1, this line becomes 4.1, that becomes 3.9, and that compensates basically, and there's other ways you could do this with different points, I know, but the point from there to there is 0.2 different. Fortunately, we don't need to do that because the darn thing is almost perfectly square, so I guess sorry, but this is such a cool thing to update. So to extrude it out, to make our actual shape, E for extrude, I'll go down negative, it doesn't even really matter how far down. So I'll just go down 0.375 with that, negative 375, and turn my sketch back on right here. E for extrude, and I'll extrude both these up, say 0.5, negative because I want it to go up in this case. So, you know what? I think I screwed up this one. This one was supposed to go down. Sorry. There we go. That makes sense. And then this guy will go up. E for extrude. This go negative 0.5. So that's what my lip will look like that we'll cut with the woodruff. I'm going to go ahead and mow and model my stock. You'll see why in a second. So new component. Stock. I'll turn off the visibility here. Sketch. Ellipse. Right here. And my stock was measuring about 7.35 by 5.4. E for extrude, 0.5. Just not too concerned with the height here. So now you can see, even though the height planes, let's see, do I want them to switch over to my wireframe? So there's my stock, and my part is kind of nested inside of it, like so. You can see how the stock is a little bit bigger as I toggle the part, which is inside of it, on and off. So I don't need the stock visible right now. We're going to use it in the cam though. Model cam. New setup, milling, find stock, change the mode to from solid. What's my solid? Expand your CAD tree right here. Expand the stock. I don't even have to turn the light bulb on. Expand the bodies and pick that body as the stock, and then set up I am actually going to use the bottom face right here. So let's see here. It's going to be a model box point bottom center because we're going to reference off of this reliable-ish flat face. The top is definitely curves. I don't want to use that. Click OK. I'm going to do a 2D adaptive clearing. We're going to do a new tool here. Let's see here. It's going to make me 34 3/8 inch Lakeshore 4 flute. So flat end mill, 4 flutes, 0.375, carbide, doesn't really matter, but feeds and speeds, I'm going to take it easy, so I'm going to just go 1500 RPMs and 0.001. I know that's slow, but guess what, folks? It's not the time here, doesn't matter. Click OK. That's supposed to be OK. And 2D adaptive here. Let's just see what we get. I didn't adjust my parameters yet. That's okay. Get a good toolpath. So this is a kind of, I think, a glitch. I think actually they know about it. It's getting fixed, but it should have picked up my stock. Since it didn't, I'll collect stock contours. I don't have to pick anything here, just have to check that. And let's do passes. Optimal load 0.375 times 0.15. Radial stock to leave, just say 5 thou. We'll come back and do a cleanup pass. No axial. Huh. Why isn't it picking that up? Maybe I have to turn my stock on. That's annoying. I think that's a glitch. There we go. That's what I wanted. I wanted it to basically have a constant engagement, which it does change a little over here. I just don't machine cast iron a lot. I don't. That's the beauty of adaptive. It means I don't have to take as many chances because it's going to keep that chip load constant. I want to do a cleanup pass, so let me turn my stock off here again. Right click, create from derived, 2D milling, 2D contour. We're done. Click OK. Does a 2D cleanup pass around that, which is awesome. Now the hard part, not really, the woodruff. Oops, that's my error. Lead in vertical might collide with stock. So I think, let's see what happens in the simulation. The vertical arc. So lead in, maybe just increase this. If it makes you feel any better, sometimes I get confused too on these errors. Huh, I happen to fix it. I'm going to lead in, so this is a great example. I don't want to lead into the back corner where it's sort of blind to me. So we're going to right click, edit, last tab. I'm going to pick the entry position and just pick a random point here on the front. Oh, come on. There we go. Well, it doesn't have to be a point on the line. You'll see it's going to move that toolpath around. It's still not going to violate your model. That way I can see what's happening with that tool on the cleanup. That one I'm fine with. Let's see here, new tool. Cutter. Slot mill. My woodruff, now here's the thing, I'm not exactly sure if it's perfect dimensions, so I know it's 14 teeth. I think it's measuring 1.395, no corner radius, shaft diameter, I'll have to check that, but I think it's 3/8. Flute length is the height of the woodruff, 0.193. It looks good. Feeds and speeds, I'm going to run at 1,000 RPMs and 1 thou per tooth. So that's pretty fast because it's got so many teeth. Post processor will say it's tool 36. And we're good. Click close this. 2D contour. So this is interesting. Pick my tool. I love this. Silly filters. Go away. Slot mill. Geometry. I'm going to pick this line here. What's my bottom height? My bottom height is going to be selection of this. What's my top height? I don't know if it matters here, but we'll say selection, selected contours would work because I picked that contour right there. So we just click OK. I think what you'll see is it's only going to machine at one height, which is okay. We can fix that in a second. Let's do a simulation. No stock. Click play. And you can see it's kind of come around like so. And ooh, we're cutting it close. Let me go check the shank dimension real quick. My bad. I must have had a brain fart last night because that is not going to work. It's too tight, but I've luckily got another woodruff. So let's edit that tool. We're going to now use one that is 1.52 in diameter with a 1/2 inch shaft. It's only going to give us 10 thou clearance, so we'll have to watch when we run it. Worst case, I'll call Keith, but I think I could trim a couple thou off the OD of the part because it's not a critical dimension, or I could buy a new tool. We'll see. And this one's 0.25 inch flutes. It's also still 14 tall. Good. Yes. Yes. Okay. So now, see the lead in, lead out is no good here. So all I need to do is manually increase that so we don't gouge into Keith Rucker's casting. So linking. Let's see here, horizontal lead in, I guess we'll just say 0.5, something crazy, make sure that works. Yeah, there we go, way better. Plenty of clearance now. Simulate, play. Cool, so the good news is we have just barely enough clearance there, but should be okay. Now obviously I'm not going to do this one pass. I just want to take a look. First, let's get our heights set. So that'll be the first pass. First height pass at least, where it goes all the way around. Then we'll duplicate this, and what I'll do is, think about it, the tool is a 1/4 inch tall. So what I'm going to do is say the height, I'm going to say the bottom height is a selection of this. And if we click OK, it's going to put my toolpath right there, but I don't want it lowered by the height of the tool. So all we've got to do, edit, heights, offset this by -0.25. That's going to give me my second pass, which will be at the correct height plane to give us a 375 tall part. Simulate, play, boom. See that? Perfect. Now let's add a bunch of radial passes, because obviously I want to go easy on this. Passes. Let's see, roughing passes. Let's see here, maximum step over, say 0.2. And let's see here, we'll do three of them. Let's say do 3 of them at 0.17. That should break it up, if I'm thinking correctly. 1, 2, 3, 4. I wanted to only. Oh, because it treats the finished passes. See, that's one reason why I normally just do multiple finishing passes. I want 3 of them at 0.17, and this will give me 3. Yeah, there we go. Let's go make some. Oh, actually, you know what? Let's make sure this is entering there. I can see it. Good. Let's go make some chips, folks. All right, here goes nothing. Awesome. You can see we're making a real chip, which I like. We're going to have to clean the machine afterward, no question. Cast iron is just, it basically turns into an abrasive chip or dust. So, you know, I don't mind doing it. I don't like doing it. And all we do is clean the machine when we're done. I put some tarps down. You might be able to see them in the GoPro background back there, or trash bags, which will just help contain the mess a little. But, you know, this is great. You would, first of all, we're getting a great surface finish there. And we would fear, if we were getting shatter and in this work holding, which we're not. Now we'll see. It could loosen. I don't think it will, but it could loosen. The woodruff is probably going to be a little bit different of a cut. And there could be like air pockets or porosity in the casting. So it could change in sound as we go, but not too, well, we'll see. So sit back, relax, and enjoy some cast iron railroad, what's this thing called again? Vulcan Boiler Handhole Cleanout cover plate. Take 5. 400 RPMs, only 50 thou step over, 1 thou per tooth, which is slow, 6 inches a minute. It's okay. Rather get the part done well than worry about the time difference. And frankly, I'd rather have a good recipe and walk away from the machine than sit there and stress about it. Well, you're hearing some run out in the cutter itself. Not a ton I can do about it. Won't in any means produce a bad part. Okay, so feed rate override, I dropped the RPMs down to 270. We'll put the card here on what that is for surface footage. And it's just so different when you cutting something like cast iron with high-speed steel versus what I normally do, which is aluminum with carbide. I bet you we can even increase the feed here. You know, there's not always a rule of thumb for chatter, but a thing to do is usually counterintuitive, which is when there's chatter, usually I decrease the RPMs or increase the feed rate. Most people think the other way around. At least that's what I used to think when I knew even less than I do now about machining. Let's see how this goes. And it happened. When it rapided in, that increase in tool, and I think I have too high a feed rate, that caused it to twist. So no big deal. We've got enough geometry now to locate off of, so let's go fix it. The left side was 1.9974 and the right side was 2.1973. So these numbers don't matter, it's the difference. So this minus that means it's 0.2 inches longer on the right. So I'm going to say, oops, I'm going to say 3.9. Oops, wrong one. This one. 3.9, 4.1. That means there's a difference in these two bars, this one and this one. There's a 0.2 inch difference, 3.9 to the 4.1. That's got it canted. Should be all correct. So we're going to try a little bit easier. Lower surface feet per minute, 300 RPMs, 2 thou per tooth, which is a pretty slow feed rate. So this is going to take a while. Again, let's just make sure we get it done. Figured out a simpler way to do the same thing, but rather than using a construction line across the top, which it can get more confusing than necessary, because guess what? Simplicity is genius, and I'm not sure this is genius, but it's better. I just created 2 points, the same 2 points really, that were on the outside ellipse and are 2 inches off center, and then I sketch a vertical dimension from that point to that point, and I've got it refixtured right now. We tightened it up a little bit more after it moved on us, and 2.201, which matches my right side dimension. I had 2.1565, and I'm a thou off. No big deal. Awesome. The other thing I'm going to do, we're going to try conventional machining, and we're also going to reduce the tool pressure by taking slightly less than a full height depth of cut, which is not shown here. I guess I lost that. I'll have to fix that here. See how I dropped it down? So I want to lower the tool pressure. That's really key here because I want something that works, and then I can build up from there. That was kind of the mistake I just made, was I didn't start low enough and slow enough, and I wasn't even thinking about not taking the full height of the cutter. This doesn't sound great. Like, I don't love this by any means, but it's a lot better. You can just tell. I don't know if it's going to come through on video, but when you see the part in person, you can tell that's a better recipe. Now, I honestly think that cutter might be dull, and that stinks, and that's my fault, and I don't have another one, and that's not normally how I operate. We've started to get a little bit more trolls on our channel, and I don't want to say I'm sensitive to them, but I want to encourage you guys out there, whether you're working with cast iron or regular aluminum or titanium or 6LV4 and stainless, you know, it's okay. We all struggle, we all fail, even on what are supposed to be easy materials. Be smart though. I'm liking this recipe a little bit better, and you know what? It's going to take a little bit longer. I don't really care. I'd rather get a recipe that works. It's not going to spin the part in the fixture or damage it, and I'll go, you know, I can listen to the machine while I can be doing some other stuff nearby. So I think we got it now. It's going to take a little while here, probably about an hour to run around this, which I know is ridiculous. And oh man, if we could have had this thing in the 4th axis with a 1/4 inch end mill, I think I would have banged out the Toolpath in like 6 minutes. I get it, folks, but still fun, and it'll be awesome to get this thing done. You can see we lifted it up a little bit higher, taller gauge blocks. That just made it easier to deal with the fixturing and getting it all positioned correctly and tightened down. All right, folks, let's see what we got. So he wants me to try the ring, but it'll be a squeeze around, and I want to check my tolerances first, which is kind of be tricky. I think I can, well, I did it a second ago before the final cleanup pass of 20 thou, and it confirmed we were on, so I don't have any real worry. So it's be 4 1/4. Can you see that on the? Well, I don't think I can take these out locked in position, but folks, how's that for tolerances? Check our OD 6 1/8 was the target. Again, we got like loose tolerances here, but let's see what we did. 6.12. If you believe these, 7, so 2 thou over across 6 inches ain't bad at all. Let's see how the fit is, because remember, at the end of the day, customer doesn't care about tolerances, they care about what they want, which is this O-ring to fit, or to stretch over it. Oh yeah, oh that's awesome. That is awesome. Oh my god. All right, what a win. Take a look. Now, I'm not even a car guy, let alone a train guy, so I don't know anything about these, but I am proud of that. I am proud of that. That's awesome.